morning, students. This is Dr.GVR Seshagiri Rao, Associate Professor in the Department of Mechanical Engineering, Institute of Aeronautical Engineering, Hyderabad. So today, I would like to discuss about shear strength of key. So how to calculate the strength of key, we will see. So already we have discussed in earlier, so types of keys. In that, the rectangular key and square key and saddle keys are important things. So in this, how to calculate the shear strength of the key is what are the relations how to use, we will discuss. So you know the dimensions of the rectangular Sankey key. So width and thickness of the key and length of key. So the width is equal to d by 4 and thickness is equal to 2w by 3 or d by 6 you can take. So here d is shaft diameter. Suppose having the rectangular key like this. So in this, this is length and width and this is thickness or height, depth of the key. If you know the shaft diameter, you can easily find the dimensions of a rectangular key. W is equal to d by 4 you can take and t is equal to d by 6. The taper is 1 in 100. See in this slide shown figure, rectangular shankies are shown. So in this W is width and T is the thickness of the key or depth of the key and D is shaft diameter. So similarly in square Sankey key. So only the difference between the rectangular Sankey key and the square key is that width and thickness are equal in this. In square key, width and thickness, these two are equal. So that is d by 4. But whereas in the rectangular key, the thickness is d by 6. See in this, the forces shown, what are the forces acting on the key? So they are shown force F and F1. So it acts opposite side. Due to this force, the twisting moment will be occur. That is the momental torque. I will tell you how to calculate these forces. So a key connecting the shaft and hub already have seen in figure. Let's take T is the torque transmitted by the shaft and F is the tangential force acting at the circumferential of the shaft. So already we have seen in this figure. Circumferential force. D is the diameter of the shaft and L is the length of the key and W is the width of key and T is the thickness of key. Take here tau and sigma c as shear and crushing stresses for the material of key. It depends upon the material, the shear stress value and crushing stress value. So now considering shearing of the key, the tangential shearing force acting at the circumference of the shaft. So how to calculate it gives torque. So how to calculate torque? Torque is equal to how much force acting multiply with the perpendicular distance. So at what distance the force is acting. So that is have to multiply here force multiply with d by 2. That is the radius of the shaft. That is equal to L into W into tau multiply with d by 2. So how do you calculate this force? Force is equal to which type of force? Shear force. That is area multiplied with shear stress. So shear stress is equal to force per L into W. So L into W means here area, cross-sectional area of the key. So you will get that torque equation. So when considering crushing of the key, the tangential crushing force acting at the circumference of the shaft. So that is, let's take F is equal to area resisting shearing and a shear stress. So L into W into tau. Therefore, torque transmitted by the shaft is, you can write T is equal to F multiplied with D by 2. That is L into T by 2 into multiply with the sigma C. Here area is L into T by 2. So why? Because we are considering here crushing. We will take length and the depth of the key. So that is thickness of the key. So the key is equally strong in shearing and crushing. Then you can write equation L into W tau into D by 2 is equal to L into T by 2 into sigma C into D by 2. So this equation when considering shearing, this is when considering crushing. If key is, so suppose if key is equally strong in these two cases, crushing and shear. So in this case, equate these two strengths, so we will get one relation. So that is, see here. So relation, so L get cancelled here, and D by 2 get cancelled. So W into tau is equal to T by 2 into sigma C. So we can write 2W tau is equal to sigma C T. So you can write W by T is equal to sigma C by 2 tau. So the relation W by T is equal to sigma by 2 tau. This is for when the key is equally strong in crushing and shear. The width to thickness ratio is equal to sigma C by 2 tau. So let us calculate T is equal to L into W into tau into D by 2. This is, first one is shear stress due to load, and this one is torque due to twisting, rotation. So that's pi by 16 into tau into dq. So rotational torque and normal torque. So we equate these two torques. So we will get a relation L is equal to 1.571D multiplied tau 1 by tau. So here you can take here tau 1, and in rotational case shear stress almost equal to shear normal shear stress. So that's why you can take tau 1 is equal to tau. So that you can write L is equal to 1.571 times of D. So this is the length of the key is equal to 1.5 times of diameter of the shaft. If you know the diameter of the shaft, you can take this relation, empirical relation, for calculating the length of the key. So otherwise, you can calculate when it is subjected to shear stress, shear and crushing, and equate these two equations and find the length of the key. So like this, how to calculate the strength of the key. Thank you. These are the references.
Like, share and subscribe. Hit the bell icon for more updates.